My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem solving questions. It has 174 data sufficiency questions. We have solved every single one of these problems. If you're interested in watching the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now we are in the middle of resolving the problems. We are on page number 278. Please turn to it. Page number 278, the very first problem in the second column, problem number 39. Problem number 39 says that we are holding 12 cards in our hand, red, white, blue and green. Red, white, blue and green. The question simply is, if we were to pick one card at random, is the probability of picking either a red card or a white card less than 50%? What are the odds, or rather not what are the odds rather, but are the odds of picking either a red card or white card less than 50%? That is all they are asking. Let's see what they tell us. Let's see what they're telling us, okay? In the statement 1 they tell us that the probability of picking a blue card is equal to 1/3. Well, if the probability of picking a blue card is 1/3 and the fact that we have 12 cards, 1/3 of 12 is 4, this implies that we have 4 blue cards. And that's all it tells us. It tells us nothing more than that. All we can gather from that is that we must have 4 blue cards in our hand, but that does not answer the question that is being asked at all. As a matter of fact, it doesn't address the thing at all, because the question here is, are the odds of picking either a red one or a white one, either a red card or a white card, less than 50%? All we gather from here is that we have 4 blue cards. This is not going to do the job. Statement number 1 does not get us anywhere. A, D, B, C, E. A, D, B, C, E. Because we just found out that this statement 1 does not get us anywhere, we know now the answer is not A or D. However, notice we did not claim that statement 1 is worthless. It is not worthless. Had it been worthless, completely worthless at all, we also would have crossed out C at this point. Because if it's completely worthless, then there is no point of putting this information from here, trying to put it with the second statement. It's not going to get us anywhere. Whatever we know in the second statement is all we would know. Adding the statement from the first statement, if we claim that it is worthless, would not do any good. We're not saying that it's worthless. It might come in handy. Knowing that there are 4 blue cards might come in quite handy later on down the road. We don't know yet. Let's see. Statement number 2 tells us that the odds of picking a red card, let's use capital letters since I've been using capital letters. The odds of picking a red card is 1/6. Again, because there are 12 cards, 1/6 of 12 is 2. That tells us that we have 2 red cards. Again, that by itself does not do the job. Now we know the odds of picking a red card, we know the odds of picking blue cards, but again, knowing that there are 2 red cards in itself is not going to answer the question, is the odds less than 50% of picking either a red or a white one? Second statement by itself is also no good by itself, so which means answer cannot be B. Let's put the 2 statements together and see if we can get anywhere, shall we? Let's put them together. Now, what's going to happen is this. What's going to happen is that we have the 4 blue ones and we have the 2 red ones. 4 plus 2 is 6. We have a total of 12, which means we have 6 cards unaccounted for. And that's where the problem is going to come in. We have 6 cards that we do not know. And the remaining cards have to be either white or green. And there are 6 of them. There are 12 altogether. These are 4, these are 2, 4 plus 2 is 6. There are 12 altogether. There are 6 cards that are unaccounted for. And we do not know how they are split. Maybe we have 5 of the white ones and 1 of the green ones. Or maybe we have 4 of the white ones and 2 of the green ones. Or maybe we have 3 and 3 each. Who knows? Who knows? And we can of course keep on going, but there's no point in wasting time. The point here is that we can keep on going, but it wouldn't serve any purpose. The point that we need to understand is that the odds of picking either a red one or a white one, we cannot answer that because the odds of picking either a red card either a red card or white card will depend on how many red cards we have, which we know we have 2 red cards, but we do not know how many white cards we have. Depending on how many white cards we have, the odds of picking either a red one or a white one will keep on changing. Putting the two systems together also does not get us anywhere. The answer is E. The answer is E. That's it, we are done. We are done as far as the exam is concerned. Okay, as far as the exam is concerned. The work that we are about to start is not something we'll do in the real exam. We're just going to actually find out what the odds are, just to show, just to see, just to understand what actually goes on here. So here's the probability. Probability of picking a red card or a white card in this scenario, because we have 2 red cards, so that's fixed. We have 2 red cards, and here we are assuming that we have 5 white cards. It's 7 out of 12. In this scenario, we have probability of picking a red card or a white card. We are assuming that there are 4 white cards, so it's 2 plus 4 over 12. And finally, let's put this a little bit lower so we have a little bit of room. If we were to assume there is 3 and 3, the probability of picking a red card or a white card is, again, the red is always 2. The red is always 2, it's fixed. Red is 2 right here. Red is 2, it doesn't change. And the white, we are assuming is 3, so it's 2 plus 3. 2 plus 3 is 5. And like I said, there is no point in keep on going. The point we are trying to make here is that if we have 5 white cards, then the odds are more than half. If we have 4 white cards, then because the red one is already fixed, red is 2, it's fixed here. And since we put red first here, so we put the 2 here first, it's exactly half. And in this scenario, it's going to be less than half. So the question was, is the probability of picking either a red card or a white card less than half? We do not know. It may be, it may not be. It may be equal to half, it may be more than half. It's not enough. Enough of the talk. Let's move on to the next one, okay? We're beating a dead horse at this point in the story. We're just beating the dead horse. Let's move on to the next one. Enough of this. Number 40. Number 40 says that the selling price let's call it P, equals cost, let's call it C, plus the markup, let's call it M. So our selling price is cost plus the markup. The question is, M, the markup, is what percent of the price? Very simple, very straightforward question. Let's look at the first statement. The first statement tells us that the markup is 25% of cost. Now listen, there are 2 ways we can go about this problem. One is to actually solve this thing, look at it in a very traditional way, very orthodox, very algebraic way, very classical way, or traditional way, or we can just plug in numbers. I like to just plug in numbers because it saves time, particularly when we're dealing with percentage problem. A nice number to plug in would be 100. So M is 25% of C, M is the markup. Let's make up a number for C. A nice round number to plug in here for cost would be 100, because we can figure out 25% of 100 very easily. So if we were to assume that the cost is 100, then the markup is going to be 25. If markup is 25 and the cost is 100, then we know that price is going to be, price is equal to C plus M. C plus M, which is going to be 25% markup, 25%, and the cost is 100. So the price is going to be 125. And it's a very straightforward question. We're just wasting time at this point. We're simply wasting time. Of course, once we know the price, we can figure out, well, the question is, markup is what percentage of P? If P is 125 and markup is 25, obviously we can figure out the percentage. A, D, B, C, E. And because we can figure out the percentage very easily, the first statement by itself is quite sufficient. We know answer cannot be B, C, or E. It will have to be either A or a D. And the matter of fact is very simple. It's 25 over 125, which is the markup over the price as a percentage. And since we are doing it as a percentage, I'm taking too much here. It's 1/5. This is silly. It's 1/5. It's going to be 1/5. It's 20%. It's 20%. Anyway, the first statement is enough. Let's look at second statement. Second statement tells us that the price is 250. Price is 250. Oh, this is no good. Bloody hell. Simply knowing what the price is not going to tell us at all as to what the markup is as a percentage of price. The question is, what's the markup as a percentage of price? How can we tell simply by knowing the price? This is not enough. This is silly. This is not enough. The answer is A. We cannot tell what the markup is as a percentage of price simply by knowing the price. We need more than that. We need something more than that. Let's go to the next one, shall we? Number 41. Number 41. Number 41, I'm warning you. I'm giving you a fair warning. Number 41 is going to get a little prickly. You understand? Pay attention. Number 41. Is 4 raised to x plus y equal to 8 raised to 10? That is the question. That is what we are looking for. Is 4 raised to x plus y equal to 8 raised to 10? That is all they are asking. And that is the question. Do you understand? That is not what is given to us. That is what we are being asked. Is this quantity same as that quantity? Let's find out, shall we? Well, what can we do? We can write this thing. We can write 4 as 2 raised to 2. And then outside we have, let's not write it like that. Let's write this as 2 raised to 2 times x plus y. And this can be written as 2 raised to 3 raised to 10, which can be written as 2 raised to 30. And now, since we have the same base, we have a base of 2 and we have a base of 2, which means these exponents have to be equal. So essentially what they're asking here is, what it boils down to is, when they ask us, is 4 raised to x plus y same as, is equal to 8 raised to 10, essentially what they're asking us is 2 times x plus y, is 2 times x plus y same as 30? Which of course is same as asking, is x plus y same as 15? That's what they're asking. Let's see what they give us in the first statement. Let's see what they give us in the first statement. In the first statement they tell us that x minus y equals 9. X minus y equals 9. Well, there you go. We have x minus y, we have two variables here, x and y. We have two equations here, x plus y equals 15. They tell us x minus y equals 9. Obviously, if we add up the two equations, we're going to end up with 2x equals to 24 and x equals 12. Obviously, we can solve for two variables because we have two equations here, two independent equations, which means AD, BCE. AD, BCE, which means the first statement by itself does the job quite nicely. We want to find out x and y, and we can find out x and y because this first statement gives us this equation. Here we have that equation. We can solve for two variables, obviously, which means the first statement does the job nicely. Which means we know now the answer cannot be B, C, or E. Now, if this is what you did, okay, listen to me carefully, which is why I warned you in the beginning that it's going to get a little prickly. When I was doing this problem for the very first time, I got it wrong. I made a mistake. I made a mistake because I did not practice what I always preach. I always remind you constantly, like a parrot. I'm repeating here. I repeat here, I stand here and I repeat here. I give you the same sermon over and over again, which is never to mix up what is being asked and what is being told. What is being asked and what is being told are two different stories. This is not what we are being told. This thing right here that we see here is not something that we are being told. This is what we are being asked. Because this equation came from this equation. And that's what we're being asked. What we are being asked, we cannot use that information to answer the question, obviously. This statement by itself is no good. All we have at this point is only one equation. This is not an equation. We cannot use this equation. We are trying to figure out if this statement is actually, what we are trying to figure out is if this equation is actually valid. So the question here, the original question was, is 4 raised to x plus y equal to 8 raised to 10, which is same as, is x plus y equal to 15? And we cannot answer that question simply by looking at this equation because we have one equation and two unknown, x and y. It's no good. The first statement is not enough. This is all wrong. This is all wrong. B, C, E. A, D, B, C, E. Now that we just found out that the first statement by itself is no good, we know the answer cannot be A or D. Let's look at second statement, shall we? In the second statement, they tell us that y over x, it doesn't really matter. It doesn't really matter whether it's x over y or y over x. The point here is, there is your second equation. Again, this equation by itself is not going to do us any good because this is just one equation. If we cross multiply, what we find is, what this tells us is that 4y equals to x. And this is just one equation by itself, 4y equals x. And that's just one equation by itself. That equation by itself, we cannot solve for x and y from that equation. So again, second statement by itself, again, is no good. Second statement by itself is no good, which means answer cannot be B. But we can clearly see that as soon as we put the two statements together, the first statement gives us this equation, second equation gives us this equation, and that equation. We have two independent equations. Now we can solve for x and y, and at the end we can answer the question. The original question, the way they asked the question, one more time, I'm repeating myself, one more time. The way they asked the question was, is 4 raised to x plus y equal to 8 raised to 10? Which boils down to, we rephrase the question, and now the question as it stands is x plus y equal to 15? Is there some 15? And we can answer that question very easily by solving for x and y from these two equations. The answer is C. Putting the two statements together will do the job nicely. And if you like, we can actually even do it. It's very simple actually. X minus y equals 9 and x equals 4y. You see? X equals 4y we can put right here. It's very simple. So if you substitute here, x equals 4y, here x minus y equals 9, this from the first statement. From the first statement we have x minus y equals 9 and x equals 4y from the second statement. We put it in here and we find that 4y minus y equals 9, which means y equals 3. And if y equals 3, then x would have to be 6, is that right? No, x would have to be 12. 12 minus 3 is 9. So if y is equal to 3, that implies that x would have to be 12. Because 12 minus 3 is 9. And the original question was, is there some 15? It turns out that the answer is yes. Yes, it is 15. The final answer is yes. The point here is not that the answer, one more time I'm reminding you, as I always do whenever the answer turns out to be affirmative, I make a point of reminding you that the point here is not that the answer turned out to be affirmative. The point here is that we are able to say definitively, either in affirmative or negative, we are able to give a definitive answer, either in affirmative or negative, to the question that is being asked here. It just so happens that the answer turned out to be affirmative. But even if the answer had turned out to be no, if we had found out that x is equal to 10 and y is equal to 3, 10 plus 3 is 13, in which case the answer would have been no. Is there some 15? In that case the answer would have been no, and it still would have been fine. The answer still would have been C, because two statements together enables us to answer the question yes or no. Do you understand? Anyway, that was it. I will see you tomorrow, where we'll continue our journey. Now, if you like, we can actually put that in here and see actually that y equal to 3 and 12, x equals to 12 actually does the job nicely. I don't know if I want to do it or not. It's not necessary. You can do it yourself, and you will see that it works out. Because obviously it works out because this thing that you see here, this equation here, is no different than this equation. This equation is derived from that equation, as you know already. I'll see you tomorrow, okay? Bye now. Because if I stand here, I'm going to keep explaining.